Good morning. So this is actually lesson 4.3, which is all about the quality of air, so air quality. And now that we're talking about the atmosphere, we need to take some time to understand that the air, the different components of the air, and all those pieces that surround us are going to be very important for how it functions. Now, in lesson 4.2, what we discussed was what the air was composed of, what it was made of, as well as the different layers of the atmosphere. But today we're going to focus a little bit more on the troposphere, so the place where the weather takes place, as well as the part of the atmosphere that we see the most results of. So when we talk about air quality, we're talking about, is it polluted or not? And what a pollutant technically is something that can damage the air in the atmosphere and have harmful consequences. So bad things are happening because this item, chemical, molecule is present. That's a pollutant. Now, one more thing that we need to add is what a particulate is. So a particulate is a solid object. It's going to be something solid found in the air, whether it's dust, sand, burns, rust, charcoal, everything. All those little bits and pieces that are in the air but are solids, those are going to be particulates. And these become extremely important because when you look out at a sunset, a sunrise, or you see sunlight flicking off things in the sky, it's usually going to be a particulate or some form of vapor. And what these pollutants and particulates do is they actually absorb energy and release it in some way. But when that energy is released, those compounds or molecules can also be inhaled by us and be dangerous or kill trees or be absorbed into water. And because of that, we see that they get circulated just like the water cycle did. So that convection in the water cycle makes things move, and if we have pollutants somewhere in that process, we're going to see that those pollutants move with the water. What's important is that these pollutants are going to come from two main places: exhaust, either from cars or from factories or from natural resources that are going to shoot those different items into the air. The three main pollutants, I guess you could say, are going to be carbon dioxides, sulfur oxides, and nitrous oxides. So anything that's a gas form bound to a carbon, a sulfur, or a nitrogen. And both of our sources, natural and man-made, are going to release these. When they do, those interact with the atmosphere. They can deplete ozone. So remember, ozone is that protective gas. They can absorb heat from the atmosphere and make the atmosphere warmer. One thing that's interesting that can happen is we can get what we call a temperature inversion. And what a temperature inversion is when the troposphere's hot-cold balance is actually flipped. So you're going to have a layer of cold, a layer of hot, and then another layer of cold within the troposphere. So cold, hot, cold is what we call temperature inversion. So rather than a hot air rising and pushing to the top, it's sandwiched between two cold layers of air. This is normally going to happen in areas where we have a lot of exhaust, as well as during the morning time. What else is going to happen because of these exhaust fumes? We're going to get what we call smog, and there's two types of smog: industrial smog and photochemical smog. And what that is that's that nasty residue or exhaust you see pushing out of old cars especially, as well as factories and warehouses. And what this smog is going to do is going to combine things like fog, smoke, pollutants, and particulates that are going to be of those same compounds. They're going to be toxic to us, they're going to fuse with water, and they're going to become acid rain. We talked about acid rain a little bit in our weathering and erosion unit, but acid rain is basically when you take water vapor in the atmosphere and you add other chemicals to it. And those, again, chemicals are caused by volcanoes as well as exhaust fumes. When you do this, you alter the chemical balance. Water is now bonded to something acidic. In America, the average pH for rain is actually 4.0. And if you remember from our water unit, 7 is going to be the most neutral, and 4 is therefore going to be quite acidic. So going to destroy metals, going to destroy statues, sidewalks, cars, things like that over time are all going to be worn down by acid rain. So that's a lot of information. We're going to see about air quality. We're going to test it. I want you really to be thinking about where is the worst air quality going to be and why, what would cause that, and then how can you analyze the quality of air if you can't just use a $10 million research facility. So we're going to discuss in length how air quality affects our lives as well as how we can test it, check it, and work with it.